Hello, I'm Jacob Cook, and this is Progress Report 2. I am doing my project on cast steel. Why I chose cast steel is because when I was working at Cummins before COVID-19, it was the main material in many components of diesel engines at Cummins. I want to study cast steel and learn what are the good and bad properties of cast steel. I want to learn why cast steel is a good choice for manufacturing diesel engines. Where is cast steel used? Cast steel is used in many industries ranging from food processing to electronic to oil and gas. Some specific industries are transportation, construction, drilling, and mining. How is cast steel processed? Processing of cast steel. Steel castings are solid metal objects produced by filling the void with molten liquid steel. Typically, the cast steel is moved from the mold after solidifying and cleaning. It is then sent through a heat treatment process. The cast steel is then inspected for surface imperfections. This is a picture of the microstructures of cast steel. According to TotalMateria.com, ferrite has a choice of 3 different positions to form based on supercooling or ease of forming nuclei. Figure 1, which is up here, shows ferrite starting to form at the grain boundaries, and if sufficient cooling time is given, a ferrite structure will form. Figure 2 shows a faster cooling rate causing a mesh-like arrangement known as Weidmann-Staton structures. Figure 3, Weidmann-Staton structures are fully formed. This is a picture of cast steel microstructures after the annealing process. Image 1 is annealing at 700 degrees C for 10 hours. Image B is annealing at 800 degrees C for 10 hours, and image C is annealing at 900 degrees C for 10 hours. You can see the effects on the grain that temperature has. As you go from image A to B, you notice the grain size becomes much larger. These are the references for the information that I used in my project. Thank you.